Hello, welcome to Multiphase Systems Part 6. So in Part 6, we'll be looking into solutions of solids in liquids. Okay, why is it important for us to learn about these solutions of solid in liquids? Because this chapter deals with crystallization. Probably later in our life, we will be dealing with crystallization concept. So this is why we have to learn about the concept in this chapter. Okay. Before we go further to the chapter, let's look what's the meaning of solubility. Solubility defines as maximum amount of solid that can be dissolved in specified amount of liquid at equilibrium. Again, solubility defined as maximum amount of solid that can be dissolved in specified amount of liquid at equilibrium. For example, if we have 100 gram of water at 20 degrees C, it can dissolve only 222 gram of argentum nitrate. This is what it means. If you have 100 gram of water at 20 degrees C, this 100 gram of water can only dissolve to 122 gram of argentum nitrate. If you have more than 222 gram of argentum nitrate, the rest will not be dissolved in this water because the water can only dissolve to 122 gram of argentum nitrate. If you say you have 300 gram, so the rest the balance, the 78 gram will not be dissolved in this water. Okay, another example, if you have 100 gram of water at 100 degrees C, it can dissolve 952 gram of argentum nitrate. I'm using these two examples to show you that, okay, at 100 gram of water, 20 degrees C, it can dissolve to 122. As you increase the temperature, the same amount of water, but at different temperature, can dissolve higher amount of argentum nitrate, which is 952 gram. So it's mean by increasing the temperature, by having higher temperature, the solubility will increase. If you have higher amount of argentum nitrate here, let's say you have 1000, so the balance of this 952, if you have 1000 minus 952, that will not be dissolved in this 100 gram of water at 100 degrees C because it can only dissolve at this much of argentum nitrate. Okay, I hope you understand that. Okay, next, let's okay, please, this is the solid will not dissolve. If amount of solid higher than solubility, solid will some of the solid will not dissolve. So please remember this have some of the solid will not dissolve. This is wrong, some of the solid will not dissolve. It only dissolve at what solubility which have at certain solubility only. Okay, let's look. A solution in equilibrium with solid solute must be saturated with that solid. If not, more solid will dissolve. A solution in equilibrium with solid solute must be saturated with that solid. If not, more solid will dissolve. That's correct, right? When the solution is in equilibrium, it must be saturated with that solid. So this water, we call it at this condition saturated condition. Okay, this is saturated solution. This is also saturated solution. So that's why if we have more solid, it will not dissolve anymore. Okay, if saturated solution is cool, if it is cool, the solubility generally decreases. If you have this saturated solution being cool to a lower temperature, okay, normally solubility of this will decrease. you have a decrease in solubility. Okay, yeah. To return to equilibrium, to return the cool solution to equilibrium, some of the solids in the solution must come out as solid crystals. If you reduce to 10 degrees C, it can no longer dissolve 200 to 22 gram of Argentine nitrate. Okay, it probably can dissolve 100 gram of Argentine nitrate only. So the rest, the balance, 122 of Argentine nitrate has to come out from this solution, saturated solution, as solid crystal. This is what this statement means. Okay, so I repeat, this is saturated solution. This is also saturated solution, but I'm going to use just only this part, this example. If this 100 gram water is the temperature reduced to 10 degrees C, the solubility will reduce based on this statement. So probably solubility becomes 100 gram Argentine nitrate per 100 gram of water. So it means 122 gram of Argentine nitrate will no longer can be dissolved in this water. It has to come out as solid crystals. That's what this statement means. Okay, I made correction to this statement. Okay, please refer to this. If amount of solid higher than the amount of established solubility of that solution, that means some solids will not dissolve. It will take up some of the solid based on the solubility, but the rest will not be dissolved. Okay, this I made correction on this statement just now. Okay, let's look at this figure. I'm going to show you what actually solution of solids in liquid means. Okay. This initially you have a solution of Argentine nitrate, which comprise of Argentine nitrate and water. This is a solution at 90 degrees C. When this solution is being cooled at 20 degrees C, you will see the formation of Argentine nitrate crystals. But you still have Argentine nitrate solution. So this is what the solutions of solids in liquids. We have solutions and also solid in equilibrium. So this solid crystal is this solid, but the solution also still contain the solid. And this process normally, when in this chapter, we'll be dealing with crystallizer. So we start to see crystals of solids that being crystals of solids. Right. Solubility is normally written like this. So you can refer to your textbook. You have a table of solubility in section 6.5, and normally solubility is written like this. This I took from the table in 6.5, section 6.5 for potassium nitrate at 60 degrees C. Okay, we remember the solubility different at different temperature. So this solubility is specifically at 60 degrees C for potassium nitrate. So at 60 degrees C, the solubility of potassium nitrate of this solution is 110 gram potassium nitrate in 100 gram of water. That means if you have 100 gram of water, it can solubilize 110 gram of potassium nitrate only at this temperature. What's interesting about this solubility data is, from solubility, you can transform it into mass fraction. If you need to do mass balance of a crystallization process, and you are not given a mass fraction at the in or out of the crystallizer, so but you are given solubility data, So solubility data, you can use it to transform into mass fraction. And interestingly, mass fraction can be transformed back into solubility data. If you are given solubility data, you can transfer it to mass fraction, and if you have mass fraction, you can transform it into solubility data. Okay, from the first part, I'll give you an example. This is where I'm going to give, this is the example where we use solubility data to transform into mass fraction. Let's say I took this one just now from the graph in chapter 6.5. Okay, this is the solubility. How I'm going to change it into mass fraction, because I need this mass fraction to do my mass balance. So I'm going, this one, this is solubility. To transform to mass fraction is we do it like this, just 100 gram of potassium nitrate divided by, we know this is actually the complete system is you have this potassium nitrate and water, right? So this is just the fraction for potassium nitrate, but the total system is 100 gram of potassium nitrate plus 100 gram of water. So you'll get your mass fraction. So calculate the mass fraction here. I'm going to show you after this how to transform mass fraction into solubility data. So you can use it to check your solubility, to use it for the question, to use it to solve mass balance. Okay, now we look into how to, when we have mass fraction, we want to transform it into solubility data. For example, we have 100 gram of potassium nitrate solution contains 60% weight, contains 16% by weight of potassium nitrate. It means if we have 100 gram of solution, 60 gram is potassium nitrate, 40 gram is water. The solubility, if you remember solubility just now, we have to take the solute divide by amount of water. We have to take the amount of solute divide by amount of water. So this is what we get. To transform it into solubility data, you have to remember it has to be per 100 gram of water. So we have to times 100 bottom and times 100 on the top. So we get the solubility of this 100 gram potassium nitrate solution is 150 gram potassium nitrate per 100 gram of water. This is how we transform from mass fraction to solubility data. This is crystallization process that you will deal in this chapter. So the basic process is, normally you have crystallizer and you have filter and probably you have dryer to dry off the solid. So you will see, you will have a solution goes into crystallizer at high temperature. It contains solid and water solution, and then crystallizer will cool the solution, and the outlet of the crystallizer, you will have solution, still solution, and some of the solid in the solution. Since the solubility reduces, it will become solid crystals. And then the outlet from crystallizer, we go to the filter, where filter will actually separate solution that you perform here, that you obtain here, from solid. Okay, the amount here normally equals to here, amount here normally equals to here, and you have dryer, you have another process here. But this is normally the general diagram for crystallization process that you will encounter in this chapter. So I'll see you in tutorial, but I want you to go through example 6.5-1 up to 6.5-3 before we go to the tutorial. Thank you for watching.